Kia ora koutou, welcome to our final climate conversation, and thank you so much to many of you who've been to a lot of these conversations, and welcome to those who this is the first one. So the purpose of this talk, so today's talk is on nature-based solutions, focusing on our coastal and marine ecosystems, and we'll have Scott Butcher and Harry Allard talking through that. And then Marie's going to give an introduction as well to the topic. Just to set the scene though, for those of you who don't know why we're having these conversations, we have a climate change strategy that is out for engagement until Monday. We've extended the deadline from today for submissions until Monday. So if you're stuck home at a rainy Easter weekend and you have nothing to do, then please put a submission into the climate change strategy. It can take as little as 2 minutes. If you just want to put 1 point, you can do that, or if you want to give us a long submission, attach a document, we'll take any forms of feedback, and there's prizes up for grabs as well. So that's great. So yeah, the final thing to say is just Tania's right here, is here. So yeah, huge thanks to Cultural Conversations for hosting us in these chats. You guys have provided the venue. We just gave a small koha and really, yeah, you've welcomed us into the space, and it's been wonderful to connect with other Cultural Conversations visitors as well. So yeah, we've brought different people into our conversations that we wouldn't have otherwise connected with, so that's been fantastic. And yeah, big thanks to Lucy, who's organised all of these conversations. Round of It's a massive amount of effort. Some of you might have been to the former nightclub that we had a presentation in. We've been over there, and rejigged things. We didn't have a screen at one point, so Lucy had to get a sheet from the hospice shop, and we nailed it up to the wall. So yeah, there's been lots of working around, but it's all been fantastic. So thanks so much for your support, and please make a submission if you haven't already. Over to Bree.
Kia ora everyone. For those of you who haven't heard me talk before during this engagement, so I'm Marie, and I am the Climate Change Adaptation Advisor at Council. And today, so we are talking, just introducing and giving a bit of context for Scott and Harry to do their presentation on the environment and what happens when climate change comes to on top of other pressures from human activity on the natural world. All right, so there will be a little bit of graphs at the beginning, but I will try and make it as real as possible. So these are our carbon emissions, and unfortunately they are not going down. They have never really gone down apart from COVID, which is the tiny little dent at the end. What that tells us is that at the end of the day, it's essential to change our transport, but transport emissions are one small chunk of so many different little chunks. So we also need to look at our waste and our buildings and our land use and a whole lot of things. But what happens with this is that we've already reached a plus 1.5 degrees on global average. It's only 2025, so hopefully at some point we can slow down. But what does that mean? What does it mean, 1.5 degrees average? Well, not a lot. Once we've said that, we haven't said a lot, and it's for the natural environment, we certainly haven't touched on what that means on the ground. This is the average. So that's the normal distribution of the temperatures we would see across the year in one place, so with the very cold there and the very hot there. And I might move a little bit, it's a bit small, sorry. When we move the average, when we move this curve, what we see is that a lot more of what is today very hot, and then quite a bit of new hot, something we haven't seen before. But the thing is, it's not that simple and straightforward. There is also kind of a spread, meaning that we see more variation, more hot, but more cold as well. It just spreads and more variability. So that's what they call the variance. So a lot more variance. And now if you mix the two, which is what's happening on the ground, You may still have exceptional cold. I'm sorry.
It's okay, that's fine.
You may still have some exceptional cold, and you have really a lot more very hot, and even more unprecedented hot. So what does it mean for the natural world? Well, it means more frequent and severe extreme in general. So this is something we all kind of understand, except for winds. In New Zealand, we might see less wind. And what we might see for storms, they might not be more frequent. We're not too sure about this, but they're certainly more severe. We'll see more volatility and variability, so cold or hot at a time where you would usually not expect it. And you might have very hot one day, and you've got shifts like this, and surprises. That's the one, since we're on uncharted territory, the surprises will be there, that's no doubt about it. And what does it mean for species? So something called phenological mismatch. So species between themselves, they time themselves, right? A species might reproduce at the time where there is certain food that's coming up. And so these are kind of changed. And when there is a mismatch, that usually touches on food or reproduction, which is the two things that will allow species to thrive or not to thrive. Some species are very sensitive to change, and some are not. But what happens to the species who are not sensitive to change, but are dependent on species that are sensitive to change? So these are the things that a lot of scientists, ecologists try to understand. Where are the weakest links? Which species do we need to keep an eye on to tell us what the ecosystem will become? So at the end of the day, it's like the whole system's resilience is challenged. And the idea of the nature-based solution really is to bolster that resilience, understand it to start with, and then bolster the resilience so when something happens, they can recover. Another problem is the twin crisis. So we've got these climate pressures that come on top of already a lot of pressure on the biodiversity loss. So I'm sorry, I always start with the heavy stuff, but hopefully a bit of hope comes behind. So yeah, a whole bunch of pressures that are exacerbated by climate change. So we really need the ecologists to come in and give them the resources to know, because we don't necessarily know what's there and how species are doing, because it requires a lot of time and being on the ground and counting species. So that's what they are going to talk to us about. All right, thank you very much.
All right, kia ora everyone, I'm Scott Butcher. I'm one of the ecologists with Nelson City Council. I'm in the Science and Environment team. And so we'll get into some of my material, and then Harry will follow along with his presentation, his detail. So this is a rather long-winded explanation of what nature-based solutions are. When I was thinking about this talk, I was thinking specifically, if we are going to really invest in nature-based solutions, we need to know what nature we have. We need to understand the species and the sites that are important to us. So I'm going to focus on that component of nature-based solutions today, and some of the actions that we're taking to address some of the impacts that are coming for some of those ecosystems. One thing that I noticed when I look at this definition as well, it seems to me there is quite an anthropocentric focus in it, and it's something I'm always, challenging in my own head as to what are we doing just for the sake of biodiversity, and what are we doing that's for the sake of humanity. And I think some of the stuff that I want to talk about is let's start exploring those species, getting back to that sort of biodiversity stuff that we used to talk about a few years ago. Okay. So one of the sites I want to talk about a little bit and explore is Pepin Islands. So I'll sort of outline 3 key locations and some of the species at those locations that are really critical. So Pepin Islands, I would say, would be one of our real biodiversity hotspots. A little while back, Harry and myself did a coastal bird survey, and we found that it's a really important roosting site for spotted shag. And we counted in the end 600, I think it was over 800 birds actually at this site, roosting at this site. Pepin Island, obviously, so 800 and something spotted shags is probably 1 to 3% of the New Zealand population of spotted shag. And also here we have a number of other species that make it really important. So the point here is that for these species to thrive, we need a healthy marine ecosystem that's not massively impacted by climate change. One of the other things on the rock stacks off Pepin Island, we found that there was a healthy colony of little blue penguins. So we put some little trail cameras out, and on the rock stack we had all these penguins coming and going from their burrows. Again, probably a stronghold because it is so isolated, and it probably has little predation because it's quite isolated. So yeah, another one of the really core elements of the Pepin Island biodiversity. So another location that's really important, and again, this is really interesting because we often think the really important places are the remote places. And what I like about Nelson in this environment is we have some really important ecology in close proximity to people. So this is Te Hununui Beach, and there's a couple of species here that are really important and potentially heavily impacted by climate change. So we have Katapo spider, and this is what we have here. I think that's a juvenile spider. And these dots here, you can see these are the locations from, I think that's iNaturalist, where these spiders have been recorded. And what that tells you is if you look at that distribution, that's all in the spinifex along the dune frontage. So on high tides and extreme weather events, that is going to get damaged quite heavily and impacted. So we need to do something about maintaining that habitat and protecting that habitat. So we need to start thinking a lot more about that. We do a little bit. We're certainly heading in that direction with what we do. But coastal ecosystems, certainly for dunes and dune ecosystems, are very, very vulnerable, and there are very few of them through Nelson. Really, there's probably 4 key locations where we have nice dune ecosystems, and all of them are under significant pressure. The only one that I'm aware that has, there's 2 sites with Katapo recorded, so that was Te Hununui, and I think Delaware Bay has had a record as well in iNaturalist. The other thing that we have here as well is a really nice population of northern grass skink as well. So the other thing that, and it's had a bit of profile in the past, is the black beach beetle, critically endangered. It's a tiny little 4-metre long beetle. That lives in a really unique ecosystem type. It's a sandy sort of substrate with sparse salt marsh or salt meadow vegetation, very, very specific. And they have surveyed recently and found it at a bunch of locations, so not just here, Airport Peninsula, Bells Island, Shellbank, and there was a 4th one I can't quite remember, but yeah, so but still critically endangered because of the limited distribution. But again, tidal regimes will probably, changes in extreme weather events would probably really impact the species as well. So the third one that I want to talk about is the Waka Puaka Sandflats. Now I spend a lot of time here. I'm a bit of a bird nerd, so I love to get down here and do a bit of bird spotting. And the entire complex of the Waka Puaka Sandflats, including the wastewater treatment plant, is extremely significant for bird life. The wastewater treatment plant is 1,200 scorp annually at certain times of the year, 1,000 plus paradise shield duck. The fernbird population has recently crashed. We don't know why. Post the August 2022 extreme weather event, the population just dropped off a cliff, and we're not sure exactly why that is, but it's really disturbing all the same. So, and you have an assortment or a range of wetland bird species here that you don't have in many locations throughout Nelson. So banded rail, marsh crake, very occasional bittern turner. But again, it's a coastal remnant salt marsh environment, but with other really important vegetation communities close by. So the Boulder Bank, you've got Kānuka forest remnants there as well. And obviously the wastewater treatment plant adds to that diversity because it provides essentially what would be an open water body, a freshwater open water body. Right. So yeah, these are some of the species that we have at the Waka Puaka Sandflats and what we're trying to protect. So we've got our fernbird there, so that's a colleague of ours who's also an ornithologist has been doing a banding project down there. We've got the banded rail, and this little character here is the marsh crake, and so they all live in that environment. Right, so those are the kind of the three key sites. Now what I want to just briefly talk about is what are we doing ourselves to enhance some of these environments? What are our nature-based solutions that we're utilising? So dune systems, the Te Hunenui dune system has received significant treatment in the past years. So it formerly had a lot of marram grass. So that on the left is a whole lot of marram grass, which is an exotic grass that binds the sands. And in Te Hunenui, that's been sort of treated and sprayed out and replanted with an endemic or native spinifex. And this is where that contaminated sawdust project occurred, and what they're doing there is reinstating a naturalised dune system. And what that will do is it will provide a buffer for extreme weather events and stop erosion of that shoreline there. And the issue here with the marram is it basically creates very tall dunes that basically when the waves hit them, they collapse them. So if you have a more sort of a subtle dune profile or full dune profile, the waves can run up it. But when you have a marram or an exotic system like that, it's actually much more destructive in terms of the sea eating into it and causing harm. Okay, so Waka Puaka Sandflat. So this is another example of some of the work we're doing that I would put in the category of nature-based solutions. We had someone come to us recently who was concerned about weed growth in some of the drains inland a little bit. And so we had an individual come to us that were concerned about weed growth. We are also concerned about weed growth within this environment because there's a lot of exotic weeds in there. So recently we've been trialling allowing a little bit of salt water back in to see whether that can kill some of the exotic grasses. And what we've found is that on a 3.4 metre tide, that's basically what we get. This is the original channel over here with no water coming in. On the left there that's what you start to get, and you can see on a 3.4 metre it's starting to get back into that original salt marsh. And if we can bring the salt water back, that is the quickest way, the cheapest way to build resilience into those ecosystems. We can do a whole lot of things around planting and weed control, but if you want to build resilience into most ecosystems, you really need to work with nature. I mean, that's the basic moral of the story, I think. So the work that we're doing at the Waka Puaka Sandflats is inundation trials. We're doing ecological restoration plans, so that'll guide us in terms of what we do in future in terms of restoration actions across that area, the entire area. We do a lot of weed control. The parks teams do a lot of weed control. Also, we have predator control. So we have volunteers who are running around tracking predators. And again, that takes the pressure off the species, and it means we can maintain the biggest populations possible of those species. And that's what we want. We know we're going to get more events like August 2022, but we need bigger populations to be able to sustain that pressure. Yeah, so and there's other bits and pieces that we're doing. We're doing a bit of interpretation, letting people know what's there. We're doing a lot of planting, but if I was to rank all the initiatives that we can facilitate, I would say planting is probably one of the ones that's probably at the bottom of the priority, because it is expensive and it's time consuming, and it ties up a lot of resources to keep plants alive in those sort of ecosystems. So yeah, so that's some of the work that we're doing to respond to some of the challenges of climate change. I'll briefly touch on this one. I don't really know a lot about this. There's been a bit of work in the Waka Puaka catchment. It's MFE grants. I think there were 15 projects throughout New Zealand selected for a real detailed nature-based solutions piece of research. All I will do really is mention that we are conducting that. That's coming from the catchment team. And Sid, who's in the catchment team, can probably provide you more details on that, but that's not something I'm directly involved with. Okay, so this was summing up sort of my key points, I guess. for us to be better at nature-based solutions, we need more institutional knowledge as to what we need to do for these different ecosystem types. The big thing in my mind is that we don't really understand what we have and where we have it. We don't understand the full diversity of Nelson species. We have some understanding, but Harry and myself, ever since I started at council, we've started to do coastal bird surveys, and we're starting to find out all sorts of amazing things. And that's only since I started in 2020. And so we have to build that knowledge. If we are to respond appropriately to climate change, we need to know more of where things are and what those populations are doing. I think one of the key points in my mind is that nature-based solutions, from what I can gather from that specific term, is that we need to mitigate multiple pressures. So, like I talked about with the Waka Puaka sandflats, we have a whole bunch of things happening in there, and I think for preserving a lot of these ecosystems, we need to look at a variety of solutions in each of those ecosystems. It isn't going to be a singular thing. In each system, there will be a whole range of things that we need to do, which actually makes it extremely complex. One of the things that I'm working with Marie on is we're trying to get a better understanding of sea level rise impacts in Waimea Inlet. It's a bit of a piece of work we're going to be working on in the next few months. That is critically important because what we need to know is what are the pressures coming onto our islands. You know, Saxon Island, Haldershore Island, Oyster Island. What's the lifespan of those islands and what is likely to happen with some of the species on those islands? So that's stuff that we're working on. This is all information that we need to know. So yeah, essentially, I mean, that's my perspective of nature-based solutions, but I think the big thing for my mind is, yeah, there's a big need for building that capacity institutionally, but also building that knowledge base as well. Thank you.
Kia ora koutou, I'm Harry Allard. I'm the Coastal Marine Scientist at Nelson City Council. I've got a background in reef ecology, reef fish ecology, marine reserves, and helping design the Marine Reserve Monitoring Programme for DOC. At Council, the Marine Coastal Scientist role is kind of about gathering the best possible technical advice on the marine area for Council decision making. So I'm going to talk about a few of the work streams there that relate to climate change and particularly the natural ecosystems that can help in the fight against climate change and how some of them are vulnerable to a changing climate. So the first one I was going to talk about are, oh no, that's not bad omen. Oh, that's alright, barely covering anything. So seagrass beds, we've got a few nationally important ones throughout Nelson, but the two I'll focus on are the Nelson Havens beds and Waka Puaka or Delaware Inlets beds. Both are pretty world class. They're home to a high diversity of sediment macroinvertebrates that are the food of many different fishes like flounder and shorebirds that are visiting New Zealand. They're a key element of the estuary in terms of capturing sediment in a sustainable way, and they're one of the biggest carbon sinks on Earth, so they're really, really significant. But that role in trapping sediment doesn't mean they're immune to sedimentation, and increased sediment in rivers is a key pressure that drives their decline. But still, we've got really good beds here and we need to keep it that way. So I was just going to touch on the changes we've seen in Nelson Haven. So this map on the right, this was done by Salt Ecology, the local ecology provider. 2009 beds, you see they're not that hot. There's some sparse areas. Is there a little laser on this? Like in here, there's pretty terrible beds just hanging on. Some denser ones here, but generally quite spotty in 2009. But then in the next decade, we saw a real increase in the quality of these seagrass beds, and you've got these really dense, almost 100% cover seagrass beds all through the estuary. So that was like a really, really dramatic increase that wasn't common around the country to see positive news stories for seagrass like that. But then we had the August 2022 floods, and that's going to come up again and again. Massive, massive deposition of sediment into Nelson Haven. It left like a 2 millimeter thick layer of mud across the whole estuary. It did disperse, but it's still remnants of it in there being kicked up over and over again, affecting water clarity and depositing on top of the seagrass, which has caused some declines. So if we look at 2024, all that great increase, I mean, it's not all lost, but you see some of those really lush beds, if we go back and forth, you know, they've kind of changed into sparser beds. And the story is that as the sediment is resuspended and slowly passed back out the estuary, that whole time, you know, it's affecting the quality of the seagrass beds. So we recorded a similar story at Waka Waka Delaware Inlet, and that was that there was an improvement over time, but the impacts of the flood event are still kind of being processed by the ecosystem. So some key bits of work, skip ahead, that we're doing related to that are for the Nelson Haven, we're getting the hydrodynamic company DHI to develop a CREST model, which is a new tool for splitting up an estuary basically into sub-estuaries, so little component areas, and then the surrounding catchment into sub-catchments. And then it uses a series of modelling processes to look at what the likely land-based sources are of sediment in the estuary. So we could say, if we were seeing, oh, there's loads of sediment going in here and smothering this seagrass bed, we could say it's likely a source over here on land, and then look at appropriate riverside plantings or other controls, different measures like that to try and reduce that. So really trying to come up with a good system there for feedback, so we could, rather than just tracking decline, we could really look at what we need to do on land to improve it. So it's not all bad for the seagrass, but it's important to remember that they don't have great resilience to insane events like the 2022 floods. Like, it's still rebounding from that. And if they're increasing in frequency or severity, you know, we can't guarantee that they're going to have that breathing room to properly recover, and you could just see a slow decline. Hopefully not, but it's one of those risks. Another key habitat I wanted to talk about, which is kind of a hot topic at the moment, are horse mussel beds. It's a species called Atrina zealandica. It's a native species to New Zealand. They are eaten, they're not particularly nice, I don't think, but there is a traditional fishery for them, but they're most frequently caught as bycatch in New Zealand. So there's a proper controlled quota fishery, but no one's really fishing them on purpose. They support fisheries because they're a nursery habitat for blue cod and snapper. As you can see, this study in Auckland 2010 found that there were 10 to 30 times more snapper on horse mussel beds, so pretty dramatic. And they also have this kind of loose effect, protecting coastlines from storm energy. I don't want to say they're like a natural seawall, but they do help disperse some storm energy. And as we all know, Tasman Bay was home to loads and loads of different shellfish beds historically, whether it's blue mussels, green shell mussels, horse mussels, scallops. There was a whole range, and a lot of them have been wiped out. But we went as part of a project called Mai Whangamoa Ki Horoirangi Mai Uta Ki Tai on a new mapping expedition throughout the bay, around the Horoirangi Marine Reserve and the Waka Waka Taiapore next to it. That was expanding on LIN's multi-beam mapping in the area. They were doing it for vessel safety, but we basically made a project to piggyback on it. We took seabed videos, we did baited video to see the fish in the area, we did sediment samples, I think 300 sites over the course of a month. That was with DOC, Ngāti Tama, NIWA, Fisheries New Zealand and the Nature Conservancy. It was a massive project, still ongoing, and it produced predictive modelling of habitats based on multi-beam data. So we've got the multi-beam of the area we went over, and NIWA can now produce maps of where horse mussel beds are, and they've done that for the area in the footprint of the survey. Next steps are potentially expanding that to see the full extent of horse mussel beds in the region, because annoyingly we found this huge bed which we didn't know existed, and it extends right up to the edge of the footprint of the survey area, and then it's presumably out beyond that, but we don't know how far beyond that. So there's still knowledge gaps there, and we need to do some follow-up work to look at what can be done. But since this is such a nationally important habitat and so important to fisheries, it's pretty key that we think about next steps and what we can do to protect them. They're very vulnerable to sedimentation, anchor damage, and bottom contact fishing methods like trawling and dredging. We've already done some minor work to protect them. In collaboration with the Harbour Masters, we reduced the number of large vessel moorings in the bay to just 5 moorings. So they're set in areas where there's no seabed communities there. It's just bare dirt. So they're not at risk of anchor scouring by large vessels anymore. But there's still work to be done. Essentially, the bay, there seems to be this vision that the bay is just muddy bottom and there's nothing to it. But that's something that could change. It's only because we've removed all that shell content that we don't have these reefs building up. There should be a muddy bottom with a layer of shellfish reef, and there's no reason we can't restore it. The method's being explored, and it's clearly a future avenue that we need to look into. Another work stream is the use of MB's EnviroLink funds. These are funds available to small councils to get them scientific advice, and because we've got Cawthron on our doorstep, we bring in a lot of these, like quite a high number of these are done by us. We bring in the money for Cawthron to then research topics that are relevant to us. Quite a few of these in collaboration with Tasman District Council as well. I'll just walk through a couple of them. This one first, Kinnabarrons mapping. That's Anna Berthelsen and Maureen Ho at Cawthron. They're using existing data where they've been out in Tasman Bay recording video for other purposes or taking photos, and then using them to map the Kinnabarrons in our region. Kinnabarrons are a really, really hot topic up north, especially around Lee Marine Reserve. I used to work on that topic for the North Island, and we know that they're extensive in the top of the south, but we don't really know the story in the same way that we do for the North Island. They can basically turn a kelp forest into a carbon source. So rather than having that kelp processing CO2 and helping in the fight against climate change, they actually turn it into like an active factory of CO2. So yeah, mapping them will be a good first step in looking at where they're prevalent and maybe starting to think about what the story is, why that happened. Generally, it's overfishing. If you take out big snapper, big crayfish, you get this explosion in Kinna and they chew the whole thing away. But right now, the Waka Waka Governance Group, which we sit on, is doing this multi-level restoration attempt. They're looking at planting green-lip mussels in areas where they historically were up in Waka Waka Taipore. They're doing Kinna removals and looking at transporting kelp from Rakiura to the sites in the Taipore. So that's going on now. Today they smashed 8,000 Kinna as part of that coal within an experimental plot. And we're hoping that monitoring that over the time shows the recovery of the kelp forests in that area. So fingers crossed, that'd be interesting. It worked amazingly in the North Island and it's never been done properly down here. So yeah, it's a first case trial. Up north it was looking at Clonia kelp, down here it's Carpophyllum. So it's all quite new, we'll see what happens. Another piece of work is Al Alder at Cawthron leading development of standards for artificial reefs. These are becoming quite popular for councils to put in place either as a restoration effort or as offsetting for a development on the coast. So say Greater Wellington Regional Council, when they were doing the ferry terminals, they put in artificial reef structures to offset the potential damage of development. But there was no standard in place for how you monitor them, what you do next, like how you assess success. Like no one really had a good idea. So Al's co-developing that, which will begin with a literature review, and then he's going to be writing up standards for councils to put artificial reefs out, which would be great. And the final one was, again, Al Alder with Lee Howarth, and they're looking at consent data from existing green-lip mussel farms, and looking at whether the provision of shell and nutrients coming down from farms can actually benefit seafloor habitats. We don't know. It's generally looked at as a potential negative, but no one's really assessed any potential benefits. Because like I was saying, it's the removal of shell has turned it into this muddy bottom where nothing can survive, but potentially under these sea farms where shell's falling back to the seafloor again, there might actually be some local benefits. So that research is going on now. We don't have any open water mussel farms in Nelson yet, so this is using Tasman data, but it's not something to rule out for the future, so if we can proceed from that knowledge being in place, that'd be great. Yeah, and that was the end. Yes, if you had any questions for us, yeah.
So we've got 10 minutes for questions if you guys are happy to take questions. I've got one, if that's all right.
Yeah.
Harry, what do you think caused the rehabilitation of seagrass up until 2019 before the August 22 event? Do you have any speculation on why the
I don't
seagrass
know.
was stored?
I think it could have just been that the practices were better with sediment controls, and there was that effort put in terms of, you've got the sediment guidance for when you're doing new development. I don't know what specifically would have changed in that window to help it. I don't know, it's not clear, but at least the flood damage is pretty clear cut what happened there. But it does show that if you could manage those pulse sediment events, it would be improving. Like if it was from 2009 to 2019, if we could get on to stopping a big storm causing that massive influx of sediment, then you'd hope those situations are still in place and it would continue improving. But, a bit of a mystery. Yeah, hi.
I guess like you're talking about bringing back the kelp forests.
Yeah.
And basically utilising nature to help fight the CO2
Yeah.
output.
Yeah.
I was just guessing, like as far as the numbers go, I think it's somewhere between 60 to 70% of all the CO2 processed is done by algae
Yeah.
in the ocean.
Yeah.
Also, on top of that, CO2 is the it's the second half of the plant's system of making food.
Yeah.
So I guess would it be more feasible in the future to make the oceans more fertile and able to support more algae and then the base of the food chain, rather than concentrating on the the smaller gains from less large scale efforts?
Yeah, I see what you mean. There's kind of a fine balance with productivity in the ocean, and you can easily reach algal bloom states where you're then suffocating, native ecosystems. So there are trials. There's companies trialing an open ocean fertilization method with these, designed pellets that would then do essentially what you're saying. And I don't know what the status of them is. I know they're doing them in New Zealand and they've got EPA approval to trial it. So people are looking at that. I don't know if that is going to be the future approach, but it's definitely an avenue that's being explored nationally. I think they're doing it down Otago ways. I don't know if it's going to end up here at all, but it's ongoing now, so people are thinking that way for sure.
Yeah. And that will tie quite nicely back into the overfishing, because more food, more fish, and then two problems all one side.
Yeah, you'd hope. We'll see how it goes. I mean, it's interesting the EPA has approved it, and I'm guessing there'll be some reports coming out of it. Hopefully that would give us a good understanding of how it could be rolled out in the future. It's all quite experimental, so yeah, we'll see, hopefully.
Sorry, just a quick one from me. I just wondered, like, if for people that maybe want to get involved in the work that you guys are doing, is there opportunities out there for other than just planting, like there's obviously a lot of research that needs to be done, so is there ways that people could get involved?
Yeah, I've got some, Scott, do you?
Yeah, you jump in up.
We've got the Coast Snap things all around the region. We just need loads and loads of data, so keep using them if you walk past them.
Snaps, or
Yeah,
the
the
picture?
frames.
Okay.
Yeah, it's actually really involved to do the analysis, but it will be really good. I just need hundreds and hundreds more photos. So
Okay.
the more people do that, the better.
And where are they located?
There's Boulder Bank ones, there's one at Cable Bay, there's one at Monaco, there's one on Rocks Road.
So are those specific sites that you want where the photos taken from, or
Yeah,
conditioned photos taken from?
there's like a metal frame and it's got a little square where you put the camera photo, like the actual lens of your phone, and then you line it up perfectly, do it in the app, and it goes on as that station's picture, so it just goes straight through. Yeah, it's pretty good. It's helpful. Tasman Bay Guardians, that's another one. Volunteering for them.
Okay.
They got all kinds of events people can join, do loads of cool stuff through them.
I think those other avenues as well. eBird, iNaturalist. When you go out, record stuff. make sure you get as many records as possible, because there's a lot of things we don't have the records for. Ornithological Society, or Birds NZ as they call themselves now, that's a group to get involved with if you're interested in science. What else? The other thing we're actually starting to do, and I guess we have another one coming up, is a thing called a BioBlitz. And so what you do is, there was one done recently at Brantford Park, and you take an area and you just comb that area with all the, you can use, we were using iNaturalist, and hopefully you have experts on site as well, but you really intensely comb an area and discover what species are at a particular location. So those will be coming up in future as well. There will be future BioBlitzes.
Cool. Thank you. I think a lady behind you kind
I
of.
just wondered, when it rains really heavily,
Yeah.
I walk along the Maitai River a lot,
Yeah.
and I'm looking at the colour of it coming down. Is there an understanding of where all that sediment is coming from, and anything that is happening to change the amount that we're looking at, and where it's going?
Yeah, there is. Paul Fisher, who's not talking this, he does river ecology stuff and river and science through Nelson. And the catchments team as well, they kind of collaborate looking at the river monitoring data and then focus plantings on the riverbanks around that. I don't know about specific areas for contribution, but that model I was talking about, that will help track some of that and help us target really bad areas. A lot of it's common sense planting in like steep catchments with exposed earth, especially post floods. There's like big bare scars and slips and stuff. And the catchments team, they're really focused on that. So I think they're making good decisions based on the mapping of the previous slips during the flood. So yeah. Hey, who's
I don't know. I don't know if you guys will 100% be able to answer, but a lot of the issues you talked about was like trawling, damaging those birds, like boat anchors, overfishing, kinner, all that kind of stuff. A lot of that is obviously public and commercial impact. What ability does council and your guys' work have to inform decisions made in those areas to reduce the impact that people can have, whether it's marine reserves or, trawling or, things like that?
Regional councils can, through marine spatial planning, they can basically put rules on an area that are analogous to a marine reserve, but for the express purpose of protecting biodiversity. So like a marine reserve kind of has that fisheries element where you're protecting a fishing resource. Councils can do it for areas of high biodiversity. We've got so many information gaps in the marine area because of that assumption that it's just mud and there's nothing there. So the first step's getting information, but hopefully in time we could really take a spatial planning approach to the marine area, which hasn't really been done. We've got marine areas of significant conservation through Nelson, they're all mapped, and that's the approach we've got at the moment, but there is potential for delineated, mapped areas with specific rules. Marlborough's done it recently, Northland have done it, a few other places, so there is a process. We're just in the early days of all that, so hopefully one day we could take a more robust look at it, fingers crossed.
And I think for the terrestrial environment, one of the pieces of work I've been involved in is ecological connectivity mapping, and potentially that could, that connectivity mapping, if we can work out the really core areas for species to move through the landscape, then potentially we can protect better those places. So yeah, that's work that's currently happening at present.
Time probably for one more question, if there is one.
I have another one, sorry. I just I've been freediving in the marine reserve, and it's quite, well, when I did it, it was quite there. But I wonder, does council have any scope on being able to expand the marine reserve, or do you do any research in the reserve to see the population grow?
The reserve is dog.
Okay.
They do annual monitoring. It's pretty good. I think the habitat for the reserve, a lot of it was just bare rock with coralline algae, which is just like the pink splodges you see. There's offshore, there's sponge gardens, and they've got lots of crayfish and stuff. I don't think the reserve ever was a big kelp forest. There's a band of seaweed that's kind of been pretty solidly there since the 40s. We've got mapping, so that's there. It seems to be improving. There was a year where there was a die-off of a bunch of their blue cod, and they don't really know what happened, and they've got ongoing problems with poaching. but the reserve is working and they are seeing increases in crayfish, so
That's cool.
seems good. I don't know about extensions. They've extended a few around the country recently, so maybe, I don't know. Yeah.
Sorry, the lady in the pink, do you want to speak?
I'm doing a dune restoration project in Kyle.
Mhm.
How effective was it not eradicating, but removing the marrow grass?
Yeah, it's a bit of a mixed bag. I think it is possible, but it's very chemically intensive. So I think that you can get rid of it. The thing that I've been increasingly, aware of is we have to really be cautious about the erosion. So if we're going from a really dense marram environment to a more sparse spinifex, then you do expose that dune system to erosion. But it is possible. It's just very, very intensive.
I might have to close off there if that's okay. Thank you so much, Harry and Scott. Yeah, fantastic presentation.